Hey guys, this is our second video in our polynomial series for Algebra 2. I'm sorry that the first video ended kind of abruptly. This one is going to focus, we're going to start here with sum and difference of cubes. We have two formulas, the difference of two cubes and the sum of two cubes. Difference means we have a subtraction sign right here, and my first term and my last term are cubed. Sum means I have a plus sign right here, and my first term and my last term are cubed. These are formulas that will not be on the ACT. These are things that you would need to remember. This little acronym across the top, SOAP, it spells soap. So that acronym will help you remember the formula. S stands for same sign. So in the difference of two cubes, if we have a minus sign in between my first and second cubed term, I will have a minus sign in my first binomial. O stands for opposite. So if I have a minus sign in my original problem, the second sign that I have will be the opposite of the minus sign, a plus sign. And then AP stands for always plus. So my last sign is always a plus sign. Same thing for the sum of two cubes. SOAP, S-O-A-P, same, opposite, always, plus. Follows the same pattern. So if I have a plus sign in my original problem, my first term will have a plus sign, my second sign will be a minus sign, and my last sign will be a positive sign. So if we looked at the next page in our packet, it should be page 3 of this first practice problem. We're going to say greatest common factor. First thing I'm going to look at is I'm going to ask myself, will 30 divide by 3? Will 75 divide by 3? If the answer is yes, then my greatest common factor number-wise is a 3. And then do they all have at least one x in common? If the answer to that is yes, they do, then we have an x as part of our greatest common factor. So first thing I'm going to do is I'm going to take out my greatest common factor of 3x. 3 divided by 3 is 1. X cubed divided by x, 3 minus my exponent of 1 would be x squared. Put my 3x outside. 30 divided by 3 is 10. X squared divided by x, 2 minus 1 is 1. Plus 75 divided by 3 is 25. And then x divided by x cancels out. So that's the first thing I did. What's the second thing I'm going to do? This is called a quadratic polynomial. So I'm going to come over to the side, and I'm going to take my 25, and I'm going to list my factors of 25. I have 1 and 25, 5 and 5. Which ones of these could add or subtract in some way to give me 10? 5 and 5. So if 5 and 5 will add or subtract in some way to give me 10, those are the factors that I'm going to use in my binomials. I will have 3x, my greatest common factor, outside. My two binomials will start with an x, and then it will be plus 5 and plus 5. Remember that if we want to check, we can check it using the FOIL or box method. Alright, so let's take a minute and let's look at the second one, example number 2. So example number 2, the first thing I'm going to look for is my greatest common factor. So pause the video for a second and see if you can come up with our greatest common factor. It needs to have either a number, a letter, or a combination of numbers and letters. All right, so if you have looked for your greatest common factor, both 5 and 80 will divide by 5. So 5 is my number greatest common factor, and they have some g's in common. My first one has a g to the 5th, which means it has 5 g's, and my second one has a g to the 3rd. So that means that they have at least 3 g's in common for both of them, so my greatest common factor is 5g cubed. So I'm going to divide both terms by 5g cubed. 5 divided by 5 is 1. Go ahead and stick my greatest common factor right here outside my parentheses. And then my exponent of 5 minus 3 would be g squared. I have a minus sign in my original problem. I'm going to bring that down. 80 divided by 5 would be 16. And then g cubed divided by g cubed cancels out. So now let's see. Let me change colors over here. And look at this. I have a greatest common factor, and then I have 2 terms left in my parentheses. I have a g squared and I have a 16. The question to ask right here would be, is this the difference of squares? Do I have a perfect square as my first term? I do. It's g squared. Do I have a perfect square as my second term? I do. It's 16. Do I have a minus sign in the middle? I do, and I only have 2 terms. So the answer to that, is this the difference of 2 squares, is yes. So I factor some more. So I keep factoring. So I come back and I come over to the side. The square root of g squared is g. G times g is g squared. The square root of 16 is 4. So if you remember from the page before in our notes, g squared minus 16 is a binomial. It's got a subtraction sign and it's got 2 perfect squares. So the formula for the difference of squares would be a minus b times a plus b. And so remember, my g squared gives me the square root of my g squared gives me my a term. The square root of 16 gives me my b term. So I have an a term of g and a b term of 4. So when I come up underneath this and I rewrite, I have 5g cubed. Sorry about that. I put a squared. Let's fix that. So I have 5g cubed, and then I have a minus b, so that would be g minus 4, and then I have a plus b, which would be g plus 4. That is my final answer right there in red. I don't think I quite have enough room to circle it, but that is our final answer. There we go. Alright, so moving down to my next one. So always, again, I'm going to look for a greatest common factor. If you look here, there's a little symbol. It's from the periodic table of elements, and it's krypton, and it kind of is a Spider-Man reference to kryptonite, and it's a symbol to let us know, hey, we're probably going to be dealing with some differences of cubes, because those are the ones that kind of give us the most trouble in Algebra 2. So if I look, I need to ask myself, is 27x cubed a perfect cube? So I need to ask myself that question. And then I need to say, is 125 a perfect cube? If I can answer yes to both of those, remember on the page before we had the difference of cubes and the sum of cubes formulas. So they both, an addition sign and a subtraction sign, will have a formula. So if I can answer yes to both of these two questions, this one and this one, then that means I'm going to use one of my formulas. There's a plus sign right here, so that means this is the sum of cubes. Well, there's a formula that goes with this. The formula is A plus B in parentheses, and then A squared minus A times B plus B squared. So there is no greatest common factor. Nothing for me to factor out. 27 and 125 won't divide by anything in particular that we need to take out. So I'm going to come over to the side and I'm going to take the cubed root of 27x cubed, and then I'm going to take the cubed root of 125. Well, the cubed root of 27x cubed, I can use my calculator. If I don't have a calculator, remember there's the Desmos graphing app that you can put on your phone, and there's a Desmos scientific app that you can put on your phone. I can take the cubed root of 27, which is 3, and then the cubed root of x cubed is x. And then the cubed root of 125 would be 5. And this will be my A term, and this will be my B term. And remember also from the page before, we will use the SOAP acronym. Make sure I spell that right. Which is the same sign here, opposite sign here, and then always positive here, which is how we can use to fill out our formula. And so now I've taken my cubed roots and I'm just going to fill everything in. My A term is 3x. I'm going to erase these lines that I used to talk about the SOAP acronym so we don't get them confused. And then my B term is 5, so 3x plus 5 times A squared means I need to take 3x and I need to square it. So if I need to come over to the side and I need to say 3x in parentheses squared, which is 3x times 3x, which is 9x squared, I can, so that I can fill in this A squared term. So that would be 9x squared minus AB means I multiply 3x times 5. 3x times 5 would be 15x plus B squared would be 5 times 5, which would be 25. Now we always need to check to see if this will factor out any more, but for the sake of today's lesson and for the sake of these notes, let's just stop here with this. But if we were in our classroom, we would keep going and we would keep checking to see what else there might be. So now then, let's look at our fourth example. I want you to pause the video for a moment. I want you to see if you can find the greatest common factor, and then I want to see if you can identify what method we might use, a difference of squares, a difference of cubes, a sum of cubes, and see if we can factor that out. Alrighty, so hopefully you've had a minute to pause your video. So if you've looked at it, my greatest common factor, if there's a negative sign here, we're going to use that as part of our greatest common factor. So I'm going to divide like this. Both 2 and 250 will divide by 2. And since there's a negative sign in the front, we're going to say my greatest common factor is negative 2. And then they have a d to the 5th and a d squared. So my d squared is my greatest common factor. So I'm going to divide both of my terms by negative 2d squared. And then negative 2 divided by negative 2 is positive 1. And then d to the 5th divided by d squared, 5 minus 2 would be 3. Plus 250 divided by negative 2 would not need a plus sign anymore. So we can't bring that down. We'll erase that. And we'll change that to a minus sign. Minus 125. And then d squared divided by d squared gives us 1. Close my parentheses. So now then, my next thing would be, I look at my first term and my last term of my binomial that I created. Are they perfect cubes, like we answered up in the problem before? If I can say yes, d cubed and 125 are perfect cubes, then I am going to have a difference of cubes. And I need to follow that SOAP acronym, and I need to take my cubed root of d cubed, and I need to take my cubed root of 125. Well, the cubed root of d cubed is d, and I know from my problem above the cubed root of 125 is 5. So remember, I take my a term and I take my b term. My a term is d and my b term is 5, and I write down my formula. And I'm going to use the SOAP acronym yet again. And I'm going to write my formula down. And my formula for my difference of cubes is going to come right here underneath my difference of cubes. So I have my a term minus my b term times my a term plus my a term times my b term plus my b term squared. So SOAP, same sign goes in my first binomial. I had a minus sign in my original, so minus sign here. Opposite means my second sign is opposite of my. These are more quadratic form polynomials, just they don't look like quadratic form polynomials at the very beginning. So the very first thing that we need to do is we need to look for our greatest common factor, like we have been, between 3y squared, 3y to the 12th, 54y to the 7th, and 51y squared. So they all have at least 2 y's in common, and then 3, 54, and 51 will all divide by 3. So my greatest common factor is 3y squared. So I'm going to take that out first. I'm going to write that outside of my parentheses. 3 divided by 3 is 1. Y, 12 minus 2 is 10. Plus 54 divided by 3 is 18. And then 7 minus 2 is 5. And then 51 divided by 3 is 17. And then y squared divided by y squared is 1. So now I have a greatest common factor of 3y squared. And then this little note right here says is the exponent of a to the x, which would be my first term, a to the x, double the exponent of b to the x. So is the exponent of, let's change colors, is the exponent 10 double of 5? Well, can I multiply 5 by 2 and get 10? Yes. So the answer here is yes, it is. So if that's the case, then it's really in quadratic form. It just doesn't have an ax squared. It has an y to the 10th. So that means it's still factorable. So I can bring down my 3y squared, and I can create myself 2 binomials. And since 10 is a multiple of 5 being multiplied by 2, then that means my two beginning variables in my two binomials would be y to the 5th. 5 plus 5 is 10. So then I come over to the side, and I have my 17. My factors of 17, I only have 2. Will they add or subtract in some way to give me 18? Absolutely. 1 plus 17 is 18. So I have y to the 5th plus 1, and then y to the 5th plus 17. And it is a completely factored polynomial in quadratic form. I'll give you a second to pause the video and see if you can answer these questions here for the second example. Alrighty, you've had a moment to answer those questions. Is there a greatest common factor? No. Is the first exponent is the exponent of my AX term double my exponent of the BX term? Well, is 4 double of 2 these two exponents? Yes. So that means it's really a polynomial in quadratic form. I just don't have the AX squared. So that means it can be factored into two binomials. My BX exponent 2 is the exponent of my first two terms, so x squared and x squared. And I come over to the side, my factors of 15, I have 1 and 15, and I have 3 and 5. Which ones would add or subtract in some way to give me 2? Negative 2. 3 and 5. So to get negative 2, 5 needs to be negative, and 3 needs to be positive, because 3 plus negative 5 is negative 2. Now, I always check right here. Right here, I have a squared term and I have a minus sign. So you always check to see, is this the difference of squares? I always want to answer that question. And in this case, my answer is no, because I can't take the square root of 5. 5 is not a perfect square. This concludes our polynomial set of videos. I would like the polynomial set of videos to come first, so the next video I will name synthetic division video 3, because that would come after our polynomial set. Remember, as always, if you have any questions, you can email me. Thanks.